Okay, so today we're going to be talking about section 1.1. And what we'll be speaking about will be um, functions, okay, and continuity. And we're also going to be talking about domain and range. And so, first of all, for something to be a relationship, well, they don't say relationship, they say a relation. You could have a graph, you could have an equation, you could have a bunch of ordered pairs, but it basically has input of X and an output of Y. And you might see it on a graph or ordered pairs, etc., as shown in example 1. Okay, so check this out. These are examples of relationship between input output. Okay, and so the question is, if you have a relationship, okay, relationship corresponds to sets like X to Y, and it can be shown by ordered pairs or a graph or an equation or input-output table. The domain is going to be the X values. So you can fill that in. That's going to be the X values. And the range is going to be the Y values. Okay, and so if you have a relation that is special, okay, we can call it a function. You're like, well, how would you call it special? Well, to be special, to be a function, each input can only have one result. You're like, what do you mean? Well, if you look at a list of ordered pairs, each X value, like this has 1, it goes just to 6. 1 could not also go to 7. Okay, so to be a function, 1 would go to 6, but if 1 also goes to 7, well, then that is just not a function. It's just a relationship. Okay, so any one input cannot have more than one output. And so that's the first thing. Also, there's something called a vertical line test. Okay, so if you can draw any vertical line and it doesn't cross the graph more than once, well, then you're going to have a function. Okay, so this would be, right here would be an example of a function because any vertical line that you draw will only cross your graph one time, so this will be a function. Each input just has one result. Well, let's talk about this. The second graph right here is not going to be a function y. Well, if you look at these points right here, this is the point 2, 2 right here, and also 2, comma 1. So 2 has 2 different results, and you can see it visibly when you draw vertical lines. And if any vertical line crosses the graph more than once, then you say, well, it's just a relation, it's not a function. And so that's going to be something we talk about, the vertical line test right here. Also, we're going to talk about domain and range. Well, let's talk about, there's 3 different ways we're going to use to talk about the domain and range. Well, first of all, if the domain is discrete, there's only a couple values, okay? A couple discrete values. Well, you can list out the domain and you put a D and you put a braces, they're kind of bumpy, and you list out the X coordinates, and you normally list them in order from smallest to biggest. So I won't get all hung up if you don't do it exactly in order from smallest to biggest, but you want to list them. And then the range is going to be the Y coordinates. And again, if it's just a couple values, you can list them and it's not going to hurt you. Notice the members of the set are going to be 3, 6, and 8. You don't list 6 twice. Yes, more than one input goes to 6, but so it's going to be a function. 1 just has one result, it's 6, but 5 just has one result. It's also 6. So it's going to be a function because each input just has one result. If 5 also went to, say, 7, then it wouldn't be a function. And so you don't list the values of the range or domain more than one time just because you already said it. Okay, otherwise it sounds like you're stuttering. And so the same with the next one. If you look at all these ordered pairs, you could list the values of the domain. It's not going to take very long. Those are just the X coordinates. It's going to be 1, 2, and 8. And then the range values are going to also be, again, put it in these braces. You can say it's 1, 2, 4, and 8. Okay, so the domain is the X, the range is the Y. Well, on the next one, although there's only 3 points that are labeled, you have more points on the graph. Okay, so you're not going to want to list them out because there's an infinitely many values on that graph that you don't want to list. So you're going to describe the members of the set. So there's 2 good ways to talk about what this would be. And one way, so first of all, this is a function, this is a function, this is, this is not a function, sorry, not a function, it's just a relation, and then this is a function right here. But to describe the domain, okay, one way to do it is you say the domain is such that, okay, and you say X such that it's kind of like thou shalt. Okay, so it's like the X values that you could put in the set. You're not going to list them. You're just going to give people directions as to who belongs. Okay, and this is called a set builder. Okay, and so what you do is you say the X values that belong in the set are such that you put that vertical line that X has to be, if you look from left to right, small to big, -3 until when X is 5. And so 5 is the biggest value, -3 is the smallest, and you put less than or equal to. Those are the values of the domain. Again, we're not going to list them because there's too many to list. And the range values are going to be the y coordinates from low to high. Okay, and so we say the y values are such that the y values are between the lowest y coordinate is going to be, looks like -2, and the highest is 4. So -2 up to 4. And again, we also do less than or equal to. Y is less than or equal to 4, but greater than or equal to -2. And so we're listing out the domain and range in a way that just describes them rather than actually giving every unique value. Okay. And there's also another way to write this, but we're going to start with this for now. Just say, hey, let's either list the set or give the set builder notation to talk about these values. Okay, the next one, is this a function, yes or no? And the answer is no, it's not a function, because 0 has an output of 2 and of 1. Okay, so no, it's not a function. And then if you do the domain, there's not very many values, so you can list them in order from small to big. And then the range values are -2, 1, 2, and 4. It's not a function, so -2, 1, 2, and 4. The next value, I should zoom in a little bit so you guys can see what I'm doing. Oh my. Well, I guess we can get that away. Here we go. Let's try the next one. The domain values are such that X is such that, and the domains are going to be left to right. It looks like our X values are between -3 and +3. So the lowest is -3, the biggest is +3, and it's going to be between those values. The range, however, is going to be the Y values. It's low to high. It looks like that is going to be from -3 up to +3 as well, and that's going to be Y. Okay, so that's the domain. Is that a function? The answer is no. Why not? Well, because it fails the vertical line test. You can draw a vertical line and it crosses the graph more than once. So this input here of 1 has 2 different results for Y. So this would be like 1, 2.9, and 1 goes to also to -2.9. So 1 has 2 different results. So no, it's not a function. The last one here is the domain. Okay, yes, it's a function. So yes, it's a function. The domain would be, there's a lot of points on this graph. So it's going to be, there's only one parameter. Okay, the X is such that X has to be greater than or equal to -4. Okay, so it's left to right. The range, however, is going to be low to high. The lowest Y coordinate of this graph is going to be Y, such that Y is greater than or equal to 0. So to make a set of the domain and the range values, you can either list them if there's a finite number that's listable, or you can describe them, okay, in a set builder type notation. So I want you to give you some options based on what you see. Now, if something's one-to-one, it's kind of like dating. You want every input to just have one output, but also every output just to have one input. You don't want 1 going to 6, but 1 going, or 7 going to 6 as well. You don't want 2 people going to the same result. And so one-to-one means each input has its own result and each output has its own input. And so it's just paired one-to-one. There's just one pairing of each value. And to check that, you can look at a list of values to make sure that each output only goes with one input, but also you can do a horizontal line test. Okay, so if you can draw a horizontal line and it passes it more than one, well then guess what? More than one input is going to have the same result. And so that's not going to be one-to-one. Yes, this is a function because it passes the vertical line test, but it's not one-to-one. Each output is not unique to just one input. And so this could be like, let's see, 2 goes to like, say, 3. But over here, 0 also goes to 3. So yeah, it's a function. Each input just has one result. So yes, it's a function, but it's not one-to-one because each output is not uniquely paired with one input. Okay, and so if you go back up, you can look at those to say, okay, which one of these would be one-to-one? And this one is not one-to-one right here, the first one. because more than one input goes to 6, so that's not one-to-one, okay? This one is also not one-to-one because it fails the horizontal line test. This is also not one-to-one. Let's see. This is not one-to-one because multiple things end up at 1, okay? This also fails the horizontal line test. This one passes it, so it is going to be one-to-one. So you can check those out and see. So the next thing that we're going to talk about would be, let me see if I can find it over here, is something discrete, continuous, or neither. Well, for something to be discrete, it's going to be a finite number of values, okay? And so some functions are discrete because of their situation. So a lot of times word problems are discrete. So like if you're like, I have enough to buy 1 kitten. Okay, good, you can buy 1. If you have enough to buy 2, you could buy 2 kittens. And at 3, a certain, like say you had $100, you're going to buy 1 kitten. If you have $200, you could buy 2 kittens. If you have $300, you could buy 3 kittens. Okay, depending you're pretending to buy a cat. But if you have enough to buy 2.5 cats, you're not going to buy 2.5 cats. That's just mean. Okay, so some values, it doesn't make sense to connect the values because for the words that involved, it doesn't make sense. And some things are just a function where the graph is continuous. So if you can graph the whole thing without picking up your pencil, that's continuous. And this would be neither. It's not just discrete values. You can't graph the whole thing without picking up your pencil, so it's going to be neither. And so if you look at these items here, this is going to be neither. This is going to be discrete. This is going to be continuous. Discrete. This is continuous because it's just a single, note. And this is neither because it's got 2 different branches. You can't graph the whole thing with 1 pencil swoop. Okay, so there's a break in the graph. Okay, and the last one here, the problem is it's not a function as it is written. Okay, so if you say up to 14 people, well, then that means each person gets a group rate of $45. If you've got 15 to say, let's make this 49 people, each person pays a little bit less. They each pay $38. And then from 50 to 100, you're going to pay $30 each. So, you're still going to have to pay per person, but the individual rate per person, if you bring a bunch of your favorite friends, is going to go down as you do this. So you could say, yes, this is going to be, the domain is you're going to have 1 person up to however many you want to bring, okay? And then also the range is going to be discrete values. So you've got, I wrote this in a way that you don't know. Sorry. If you look at this, it's like it's from 1 to infinity, okay? A different way to write it would be x such that x is going to be greater than or equal to 0. Okay, so I kind of foreshadowed this method here where there's an interval of all the values between those items. So I am not going to put this here right yet. And so this is not necessarily, we'll talk about this in a minute, okay? Because technically it's not every single value from 1 to infinity because the decimal, I'm fractional people. So let's stick with this, greater than or equal to 0. And then also the values are going to be 26, 30, 38, and 45. Those are the values for the range. And so just kind of talking about this, now I would say x has to be an integer here, okay? So that would be another parameter we would put on this, but we can talk about that later as well. You could kind of write that as a parameter. The next thing we should talk about would be, what are those forms you're talking about? When you were a little kid back in the Algebra 1, you wrote x is less than 2, okay? That's what this graph right here looks like, okay? And so the thing is, yeah, that's still true, but we can fancy it up to say, if you're solving a problem and say, well, what's true about this? Well, that means the values that are shaded this is a set builder, okay? We're not going to list out the values in a set and put commas between them because there's too many to list, okay? The interval notation is going to be when you mean a whole bunch of values from small to big, you can actually kind of go like this as shortcut. So here is a longer one. We're like, oh, it's less than or equal to less than 2. Notice it's an open circle. This means the smallest number that's shaded is negative infinity. And because that's not a value, it's just a concept, we're going to put a parenthesis there. Anytime you write infinity, you do a parenthesis. And then anytime you write a number, if it equals the value, then you put a bracket, okay? If it's greater than or less than that value, you're going to put a parenthesis at that number. Okay, so at this number, because it doesn't actually equal 2, there's an open circle there, you would do this. If it was filled in right here, you would write from negative infinity up to and including 2. It's always small to big. Left is the smallest number and big is the largest number. So, if we practice writing these next things and say, hey, let's practice, set builder, you just would write X such that and put the braces around any of these things because those are valid parameters. But if you wanted to do it an interval for each of these things, you could look at the picture of it. So if X is less or equal to -3, okay, at -3, there's a solid circle and it's going to be to the left. The interval that would be spoken of would be everything that's shaded is from -infinity up to and including -3. So we're going to do a bracket. Okay, do you see how that's a bracket? So that means 3 is included. The next one is just shaded from 0 up to 4. Okay, so at 0, it's filled in, but at 4, it's an open circle and it's everybody between there. Well, then you do this. You do a bracket at 0 and your biggest value is going to be 4, but it does not include 4. So it'd be every decimal, every fraction, every value between 0 and 4, including 0, but not including 4. And then the last one would be greater than 5. So at 5, it's an open circle. So that would go from 5, not including 5, to infinity, but it doesn't include infinity because infinity is a concept, not a number. Okay, so that's how you write that graph. So I want you guys to kind of start thinking, how do we talk about domain and range? How do you speak of a group of numbers? Do you list them? Do you want to write a set builder where you kind of put fancy brackets to tell the parameters of something being a set? Or do you want to do the interval from small to big of all the values that are between it? So if you look at this picture, you say, okay, let's talk about the domain of this graph. Okay, they could give you an equation, they could tell you points, but in this case, they give you a graph and they say, okay, can you talk about what this is? Well, if you want to talk about domain, that's left to right. That's going to be how far does your graph go? And because there's arrows, it's going to actually go forever left and right. So the interval you could put, and it's kind of weird, is from -infinity to +infinity. Okay, that's left to right. Okay, that's the X values that will be on this graph. The range, okay, is going to be from low to high. Okay, that's the Y coordinate. So it's going to go from -infinity until, looks like it's up till 3, and it stops at 3. Okay, so low to high is going to be the range. And so, it's kind of weird. How far does it go left and right is going to be the domain. How far from low to high is going to be the range. So our domain in set builder is all the values of X such that what? X is from -infinity, any value you see there. And so the easiest way to write that is, because we're not going to list it, would be X just has to be a real number. And that says X is an element. That's a Greek letter epsilon, and it's a lowercase e, and then R means real number. So as long as it's a real number, it's fine. And so it could be decimals and fractions from -infinity up to +infinity. Any value will be a member of the domain of this function. And then the range, again, you describe it, because I'm not listing out all the points that are on this graph. It's going to be all the Y values that are less than or equal to 3. Okay, so basically you can write it as an interval, every value from -infinity up to 3, including it, or Y is less than or equal to 3. That means the same thing. Okay, so we're trying to write the domain and range. So let's try the next one. Well, this is not a continuous interval of all the values from low to high or left to right. And so we can't really express it this way. So what I would say is we could say, let's list them out. And so fancier than just making commas would be X such that X equals, and you would list the X coordinates like -3, -2, and put commas between them. -1, 1, 3, and 4, I believe, are the values. And the range are Y such that Y equals, and just these specific values, -3, -2, 1, 2, 3, and 4. Okay, so there is no interval because it's not all the values for an interval. Okay, and so there's gaps within them. So you cannot necessarily say, hey, there's an interval. Okay, in the back, we can talk about, let's see if I can find this. On the back, again, we can do domain and range. And I think the big thing is that if you've got domain, it's going to be from left to right. Or wait, sorry. Yeah, left to right. Domain is left to right. And so there's two different domains here. Okay, the X values from left to right are going to go from, it looks like -3 up to 0. And then also you can put union between two different groups. It looks like the X values are from 2 to 4. Okay, so the domain values are when X is between -3 and 0 and from 2 to 4. The set builder way to write that would be, it's a little trickier, okay? Interval notation tends to be a lot more ninja-like and fast. And so you can write X is such that X is less than or equal to 0. So less than or equal 2, and greater than or equal to -3. And, okay, and you can write or. What are the x values are between 2 and 4. So x is less than or equal to 4, but greater than or equal to 2. Again, we're describing the x values of what it's between. And then the range is going to be the y-coordinates from low to high. So there's, again, 2 groups. So this first group right here would go from when x is -2 up to -1. -2 up to -1. Again, it's a value, so it's filled in point. So we're going to use the brackets. And then we're going to go from, looks like from 1 up to 2 for the y. From 1 up to 2 in all the values between there. So again, for y, you can say, okay, y is less than or equal to 2, but greater than or equal to 1. Or, and that's this part right here. And then also you've got the y values that are from -2 up to -1. So these pieces are a little bit weird, but again, we're looking for the graphs, like how far left and right is this interval, how far left and right is that, and that will give you your domain. And then the range has to do with low to high. What y values will you see in your resultant points? And then the next one's going to be the domain. So notice, how far does this graph go left and right? Well, it goes forever. And so we can say, basically encompasses x such that all you got to do is it could be a real number. And the interval is from -infinity to +infinity. From left to right, that's how far your graph will go eventually. From low to high, your graph will also go y such that y has to be a real number. And it goes from -infinity to +infinity. And then the last part is going to be the domain has 2 pieces, okay? It goes from -infinity until it looks like here. And it goes from here over. So let's write this. So if we write, all right, let's see. Okay. So if we write from -infinity, x is -infinity until it looks like -1, but not including that, because notice the open circle. And then also from when x is 1 to infinity. So we go 1 to infinity. So because it includes the value for x is 1 until x is infinity. And then look at the range. The range goes, the lowest the graph is going to go to is -infinity. The highest the graph will be is to +infinity. So that's going to be everybody. And then that means that your range is just real numbers, because it goes from lowest to highest values on the graph. The domain is a little harder. We do x such that x is going to be, looks like x is less than -1, or x is going to be greater than or equal to +1. I don't know why I wrote this right here. Anyway, so again, domain is left to right, range is low to high, okay, from low to high.